Yeah, so before I start, who here is participating in the ring? Oh, that's like 40 people. And who's been here with us from day one? One or two? Nice. So I want to start with the origin story, basically. So what happened end of 2010 is there was a network engineer with a problem. He was seeing some trace routes die. He was seeing packet loss, and he couldn't really pinpoint what was going on. Some destinations were reachable, some destinations were unreachable, not always at the same time, and the trace routes would stop sometimes in one place, sometimes in another place. So it was all very confusing and he couldn't figure it out. So he joined the NLNOG IRC channel, which you are all on or should be on. And he started asking people for trace routes and pings from their point of view. So he could only do his trace routes from his network, and he wanted to see the other side. So he asks around on IRC, and he gets pastes, and he gets emails with trace routes and pings and everything. And he goes on debugging and debugging, and he comes back on the IRC channel, asks for more trace routes, and this goes on and on for weeks, literally. And eventually, he did find his problem. It was located around a large internet exchange here in Amsterdam. But the point of the story is that people got really fed up with him continuously asking for data. And so in this discussion, somebody comes up with the idea, hey, what if we all spin up a VM or a physical server in our own network, and each of us gives everybody else access to that server so that you can get your own data and run your own debugging from my network, and I don't have to be in the middle and pass on the data that you need all the time. So that was actually pretty easy to set up. It took a very short time before some people set up servers. Then with a group of 4 volunteers, Peter van Dijk, Job Snijders, Edwin Hermans, and myself, we spent some time around Christmas 2010 mostly drinking the wine collection of Job's flatmate at the time, but also coding up some infrastructure to manage this stuff. And then in the beginning of January, the NLNOG ring was born with this lovely email to the NLNOG mailing list. So how this started out was with 10 participants, also 10 ring nodes. Most of them at the time were physical servers, because not everybody had a VM platform in their network yet. This is a bit different these days. We also realized immediately that this could grow pretty big. So we configured a Puppet server to do configuration management and to automatically deploy configuration SSH keys of the different users, etc., on all the different ring nodes, so that we could manage the whole thing from a central place. Some of the early participants started working on tooling. We got the first tools, ring ping and ring trace, which I will tell more about later. They can be used to do some troubleshooting from different vantage points. And we had an IRC channel, hashtag ring on IRCnet, and we set up a mailing list. So the first year went pretty well. We started off only with participants in the Netherlands, but after 6 months or so, we gave a presentation at one of the RIDE meetings, and we started opening up for international organizations as well. So a year later, around 2012, we had about 100 participating organizations and the same number of ring nodes. And that's when we started with the first problems in the scalability of our management infrastructure. The Puppet server was running on a small VM provided by InTouch, and that was nearing its limitations. So we set up a fundraiser to get some money to buy our own infrastructure for this project. The goal was to get enough in for 2 physical servers in 2 data centers, and it was actually very, very successful. So we ended up with 4 physical servers that people donated, including co-locations, and enough money to buy a 5th one and host it. So that gave us plenty of capacity to build our management infrastructure for the project. And these were all the companies that helped us with that. So the years after that, once we had our infrastructure in place, we started focusing more on tooling. We added a looking glass, a BGP looking glass, which currently has around 120 active peers. And it also does RPKI validation, so that's another useful tool to check your ROAS if you want to. We added ring curl, which is a distributed version of the powerful curl library that you can use to debug CDN troubles from various different vantage points. And several participants wrote ring SQA and an accompanying SQA collector. Ring SQA is a tool that runs on every single ring node, and it pings and traces every other ring node. And then if it sees, suddenly sees problems reaching several ring nodes at the same time, then it can notify you via email or via Slack that there is a problem somewhere, probably with your network or somewhere else on the internet. And the SQA collector collects all the data from the different SQA instances on all the ring nodes, and it tries to correlate things. So it tries to correlate events that happen all over the internet and tries to see if there are certain ASNs in the path that are broken from multiple ring nodes. So you can identify outages in large transit providers, for example. In 2016, we ran into scalability problems again. The ring had grown to about 400 nodes, and again, we were having issues with our central Puppet server. It basically couldn't handle the load anymore of 400 nodes coming by a couple of times per hour to get a configuration and apply it. So we decided to move to a different model. We moved to Ansible in pool mode. In short, this means that we keep our entire configuration in a GitHub repository, and every hour Ansible comes by, does a git pull, and runs locally on the ring node itself. So there's no longer a central server that manages everything. Every node runs its own Ansible and applies its own configuration, and that way we can scale further. More details on this architecture and on the whole migration can be found on the link at the bottom, the presentation I did in 2017 on this topic. This move to Ansible also allowed us to put in some automation based on the successes of the Ansible run. We were starting to mark nodes inactive that did not have a proper Ansible run and thus were broken. With 400 nodes in the system, it happens a lot that some nodes are broken for whatever reason, and having them not be included in tools like ring ping makes it much better to work with the ring. So we added that. And in the years after, we mainly saw a lot of growth until 2019, where we reached the milestone of 500 active nodes. As you can see, we are all over the world. We are currently with 592 active nodes spread over 55 countries on all continents, except Antarctica. So if you know someone with an AS in Antarctica, tell me. Also in 2019, we added more monitoring. You would think that a ring node is a simple VM with an IP address and a bit of software installed. How much can go wrong with that? Well, a lot of things can go wrong with that. NTP can die, DNS can die, IP gateways can disappear, you name it. So we implemented some more detailed monitoring to keep checks on that and to email people that have broken configurations. And one of the main points here that we find is broken IPv6. Now, for Jan, we did our part in fostering IPv6 deployment by making it mandatory to have an IPv6 address on a ring node. IPv4 is optional, but IPv6 is mandatory. Nevertheless, we find a lot of cases where IPv6 connectivity on a ring node is broken, but IPv4 still works, but never the other way around. So we never have cases where IPv4 doesn't work and IPv6 works. So sadly, after 10 years, IPv6 is still a second-class citizen also on the ring. Then finally, 2020, we used the Corona lockdown period and all the spare time that gave us to build a nice new website. Our original website was on WordPress, which is way too bulky for the purpose that we have, and it was a lot of work to maintain as well. So we moved to Hugo, which is a framework to generate web pages, static HTML pages from Markdown files. So now our website is simply a bunch of text files in a Git repository and a small script that's run by Ansible to deploy it on our web server. So over the years, we've had many users telling us that they are happy with the ring. We get these emails from time to time telling people how they're using the ring. And that ranges from debugging network problems to CDN issues, but also application issues like troubleshooting mail servers from different parts in the world. So it really helps us to keep going and to put effort in this project to see that so many people are actually using it. We're also mentioned in several research papers on network detours and routing overlays. So that's also cool that the academic world has also discovered our tooling. And then for this occasion of a 10 years ring, we made a little demo. So I'm going to see if that works. Oh no, a security warning.
Martin, ik denk dat de wifi uitstaat.
Uh-oh.
Yeah, what shall we choose?
Gasten wifi?
NLNOG Day, I would say.
Where is it? Oh, there. Insecure?
Insecure, why not?
Insecure, yeah.
There's no password. It's easier. It's always better, right?
Let's see if this works. Not really. So yeah, perfect. So what do we need for using the ring is we need a key, an SSH key that everybody supplies when applying to the ring in the application form. And you need a working SSH agent. So we're trying this out now, and we're seeing that our ring ping fails. So we first need to set up our SSH agent. So we start the SSH agent, and we add our SSH key to it. Bum, bum, bum. I'm a slow typer. We can see that the agent is loaded, and now we should be able to log in on our ring node, and we pass the agent to the ring node with the SSH-A flag. We have our agent, and we check if we can now hop onto other ring nodes, in this case FreedomNet 01. And that works. So now we should be able to use some of the tools that we have available. And the first tool we'll try is ring ping. We're going to try to ping the NLNOG ring website from 20 different nodes spread all around the world and see if that works. Takes a bit of time. And voila, our website is reachable from everywhere. Another useful tool that we have is ring trace, written by Teun over here. Ring trace allows you, it's similar to ring ping. It allows you to do distributed things. In this particular case, a trace route. You can do trace routes from different ring nodes, choose which ring nodes, and it will display the trace routes visually. So what we're going to try now is ping a trace from 10 different ring nodes to NLNOG, to the ring.nlnog website. And we're using the -A flag. That means that we're going to see the different ASNs in the path instead of different router hops. So that makes the picture a bit cleaner. And now we can display the results in different output formats. We can store them in pastebin, or we can create pictures. The default is a JPEG file, and that you can use in your presentations, etc., if you want. So our trace completed. So now we copy the JPEG file to our local workstation, and we open it. And we have a pretty picture of a trace route. So we see at the bottom the PC Extreme AS. That is the location of our ring.nlnog web server. And we can identify, in the middle, we can identify transit ASNs and things like internet exchanges. We identify internet exchanges based on the IP addresses that we see in the traces. The most powerful tool we have is ring all, and this allows you to run arbitrary commands from different ring nodes. In this case, I'm doing a dig, I'm doing a DNS lookup for the IPv6 address of the NLNOG website. And I want to see if it looks the same from everywhere in the world. So if we get the same DNS response everywhere. And that is the case. So ring all is very powerful. You can do, you can basically run any command or script that you have, that you would like. But it might be that you want to do extra things. And for that, we have an API that you can use. So these are the available endpoints that we have. So for example, if I want to get the information of ring node Amazon 01, one of the ring nodes provided by by Amazon. I use this endpoint, and I get all the information about that node, such as geolocation, IP addresses, the current status, is it reachable over IPv4, is it reachable over IPv6? So I can use that in my scripts to do some things with. The second call I just did was based on the participant ID. I see which nodes Amazon has, and that's 23 of them all over the world, basically. So that's a short demo of what you can do with it. More information and other tools are on our website, ring.nlnog.net. And if you have any questions, you can also send us an email. And I'll go back to my slides. So to wrap this up, I want to give a huge thank you to all the participants, all 496 at the moment of them, for supplying VMs and servers to make this project possible. Also a huge thank you to the over 50 people that contributed code in our Ansible and other repositories. And of course, the current providers of VM infrastructure and co-location to keep all of this running. Lastly, of course, our website, and on the GitHub link in the middle, you can find our complete code that we use to manage our infrastructure. So if you want to play with Ansible yourself and you don't know where to start, we have some good examples of how to do things. And at the bottom, of course, if you have any more questions after this, you can email us. Thank you.
So, thanks, Martin. I see that we do have a question there.
Hello, I'm Andre from RipenCC. I would like to ask how you deal with abuse and how you manage, well, what is abused and what is not, because it's very, not very clear what is considered to be good to do on an NLNOG ring and what is behind the line. And maybe somebody has line in different place.
Well, in principle, the ring is meant to do short-term troubleshooting. It's not meant to do continuous heavy load measurements all the time, because if everybody would do that, we would run out of capacity on the ring nodes at a certain point. That's also why we have ring SQA, which does trace routes for you, so that not everybody has to do that themselves with their own script. As of abuse, even with 400 organizations, it is still a manageably sized community. So we have not encountered many cases of abuse. We've had one incident where someone found it a good idea to test their DDoS mitigation center from the ring, which we quickly discovered, and this participant then was terminated immediately for a few years. After that, they came back begging, and we let them in again, and they behaved. We also recommend people to rate limit the traffic from their ring node, because the purpose is debugging, and the purpose is not testing the bandwidth of your servers.
Thank you.